for this lab is to practice using the analog write function on the Arduino software program. The first one, we're going to reduce the voltage and for the LED about 25%. So in the program, we need to set up the pin number, which is number 6, and that is a PWM pin where we can send different readings for the analog write. Then we're gonna set the pin to as gonna be as an output, and the analog read values from 0 to 1023, but the analog write values can only be from 0 to 255. So I already calculated that about 25% of 1023 is 6375 for the analog write. So let's plug it in and see what happens. Okay, and as we change the value, we'll see how this the brightness changes. So the next one will be 127.5, and that is the about 50% of the voltage that Arduino can provide. So let's upload that to Arduino. And it's just a little bit brighter, as you can see. So now let's change it to 191.25, and that is about 75% of the voltage. And let's see how the LED changes. And it's just a little bit brighter. And if we just use the full voltage, will be input, it will be 255. So if we want 100% voltage that the Arduino can produce, it'll be 255. And so that is the practice of using the analog write function. For objective 2, the intent is to become familiar of using DC power, and here we have a 9-volt battery for our DC power to produce to the motor, and then we have a potentiometer here that it will regulate that voltage or the amount of current flowing through it. Arduino is can provide about 5 volts. So in here we have 9 volts. But you will see, like, I'm turning the potentiometer right now, and it's taking a little bit of time to get the motor started, almost till the end where there's a maximum resistance or less resistance. There it goes. So the maximum current that this motor can actually use is 40 milliamps. So I will show you a picture later about what I was able to measure through with a voltmeter. The maximum current that the Arduino can produce is about 20 milliamps per pins. So as you can see, there's we have 12 pins on one side and 5 on the other side. So there's quite a bit of current that the Arduino can provide. And The only drawback of regulating the amount of power that we're providing to the motor with just using the potentiometer is that a lot of heat is dissipated. So that amount of heat actually would be better controlled and used if we were to put a transistor. So this concludes objective 2. Okay, so we already took a look at the schematics and then how we were going to assemble in the board. And we also looked at the program that I already downloaded to the Arduino. And now let's take a look at some of the components that we have. So we have the transistor right here, with that allows us to control a circuit that can carry a higher voltage that the Arduino can handle. So the Arduino can handle 5 volts, and we have a 9-volt battery here, and it acts as an electronic switch, and it has the 3 connectors. So we have the gate that we have connected to pin number 9, digital PWM output, and then it has the drain that is connected to the diode, and then the source pin is connected to our ground. So, and the diodes is connected in parallel to the motor, and that is to make sure that it protects the circuit from any back voltage that the motor can cause when it's reducing or increasing the speed. So, and then the potentiometer again is regulating the current flow that is going through the whole circuit. So let's take a look and see what happens. So as I adjust the potentiometer, the motor will start running. And just by the noise, you can see that it's moving faster, or it's moving lower. And that concludes the lab. Okay, now we're going to do objective 4 for lab 5. In this one, we're still using the motor, and we basically left the circuit the same as objective 3. But in here, we are going to give it a threshold of 500 for the potentiometer. And then we have added a push button. So that means that in our sketch, we need to add the pin for where we're going to get the information for the push button. I created a constant called threshold for 500 that I'm going to use with the potentiometer to evaluate if it's higher or lower. And then basically the rest of it is the same. So if we continue looking at the sketch, in here I have an if-else statement, and if the potentiometer value is larger than the threshold, then it's going to set a state of high. If not, it's going to be low. And this is going to be used later on for turning on and off the motor. Then we're recording the state of the push button that is normally high when it's not pressed, and it turns low when it's pressed because of using the resistor, the pull-up resistor. Then I just created a bit of guide here so then we can see it later on the serial monitor. Then the next, my if statement, if the push button is low and the state of the potentiometer is high, then I want to turn on the motor, and it also is controlling the speed with the map. And then the analog write is providing that information, and that's this pin number PWM9, the pulse width modulation pin 9. And if it's in this range, is going to give me some speed for the motor. If it's not, if there's no if statement, it goes to else, I just basically gave it 0. So let's see what happens to the motor. Get the serial monitor here. So right now the potentiometer is low, is less than 500, and the push button state, let me just stop that for a minute. The potentiometer value is less than 500, and the button state is just 1, which just means high. I'm not pressing it. If I was to press it, then it goes to both 0. But because the push button is high but the potentiometer is low, my if statement is not true, and then that means it goes to the else. So let's give it a try now with everything hot the way it's supposed to be. So you can see the motor is moving because the potentiometer value is larger than 500. And I can adjust the speed. It's a little hard to tell, but and that's what Objective 4 is, being able to have 2 controls to get your motor running.